Hello and good morning, my dear friends, my dear viewers. Today I am going to discuss about the chapter regarding your redox reaction, chapter 8. So, what is the redox reaction? What is its effect? How the redox reaction occurs? These are my basic objectives. Okay. So, without any delay, let's get started. So, my dear friends, ये जो वीडियो होगा ये बाइलिंगुअल होगा, मैं पहले से ये बताना चाहता हूँ और सभी मेरे दोस्तों को ये वीडियो समझ में आए, यही मेरी उम्मीद है। तो चलिए पहले हम बात करते हैं ऑक्सीडेशन के बारे में। तो ऑक्सीडेशन हम कब बोलते हैं? देखिए, ये मेरा आपका सुझाव है, जब भी कोई ऑक्सीजन की एडिशन हो रहा है, जहाँ भी कोई हो रहा है, वहाँ पर आपका ऑक्सीडेशन हो रहा है। ठीक है। सो एडिशन ऑफ ऑक्सीजन इज एन एग्जाम्पल ऑफ ऑक्सीडेशन. Okay, after that the opposite word, that is the removal of hydrogen. Okay, so this is another type of oxidation. When there is a removal of hydrogen occurs, then we can say oxidation occurs. And the next one is the addition of electronegative elements. So when there will be the electronegative elements, that means the fluorine, that means the neons, like the electro negative elements are added, then we can say oxidation occurs. Okay. After that, when there is the addition of electropositive elements also. So the here is the here is wrongly written here, that is the removal of electropositive electron. So when there is the removal of electropositive element occurs, we can say oxidation reaction occurs. Okay. After that, the loss of electrons is an example of oxidation, and increase in oxidation number is an example of oxidation. Okay. So these are the 5 steps, 5 procedure how the oxidation occurs generally. After that, the reduction. So what do we mean by the reduction? The removal of oxygen. So my dear friends, what is the removal of oxygen? When there is the hydrolysis, that means the removal of oxygen occurs. This is another example of reductions. Okay. After that, the opposite of oxidation, that is the addition of hydrogen. Okay. When there is the addition of hydrogen occur, we can say the reduction occur. After that, the removal of electronegative elements. Okay. As I have discussed, when when there is an addition of electronegative element, we can say the oxidation occurs. And on the other side, on the contrast of the other side, when the removal of electronegative elements occur, we can say there is a reduction occurs. After that, the addition of the electropositive materials or elements. Similarly, the electropositive materials when added, we can say the reduction occur. Okay. So after that, the next point is the gain of electrons. When there is then element is gaining some electron, we can say the reduction occurs. Okay. Similarly, when there is a decrease in oxidation number, we can say reduction occurs. So my dear friends, these are the total difference, and as well as the different process how the oxidation and reduction occurs in the different chemical reactions. Okay, my dear friends. Then next one is the reducing agent. So what do you mean by the reducing agent? Very important one. There is a confusion in between the reduction and reducing agents. Okay. So what is a reducing agent? An agent which act as which reduces other elements are known as the reducing agent. That means the donor of electron. Okay, the electrons are given by an element are known as your reducing agents. Okay, so generally we can say when there is an element is donating some electrons, we can say it is an reducing agent. Okay. So after that, the oxidizing agent. So what is an oxidizing agent? When the electrons are accepted by an element. So generally we can say the electronegative elements are the oxidizing agents, and electropositive agents are the redu redu reducing agent, or we can say the metal ions are generally reducing agents, and the non-metal ions are generally the oxidizing agent. Okay, so these are the basic difference between the reducing agent and the oxidizing agent. Okay, so in the next we can discuss about the redox reaction. So when the what is the redox reaction? When we can say the redox reaction, a reaction in which both oxidation and the reduction takes place simultaneously, we can say this is the redox reaction. Okay, so this is the general idea about the redox reaction. Sometimes we can observe in the different peptides the redox reaction occurs. That means the both oxidation as well as the reduction reaction takes place simultaneously, okay, in a cell. So this is a idea about the redox reaction, okay. So after that, the next one, the oxidation number. So what is an oxidation number? So my dear friends, it is a charge that an atom appears to have to given species when the bonding electrons are counted towards the more electronegative atom. So my dear friends, what is an oxidation number? It is a charge of an atom which has appeared in the given species when the bonding electrons are counted towards the more electronegative atom, okay. So this is the idea about the oxidation number. How the oxidation number are calculated, what is the different rules and regulation to calculation for the oxidation number. So let's discuss about that. So my dear friends, the oxidation number, okay, of all the elements, that means the oxidation state of all the elemental forms in a standard set is taken as 0. So in general idea about that, the oxidation state of an element, that means the chlorine, that means the fluorine, we can say the ozone or any normal element at the standard state is taken as 0, okay. So second one is the common oxidation state of an element of first group is +1, and the common oxidation state of the element number group element of second group we can take it as a +2 of oxidation state, okay. For the ions, that is composed of only one atoms, the oxidation number is equals to the charge over the ion. So when there is a, we are calculating a oxidation number of a ion, we can simply calculate the, or simply if we know some simply about the ion, okay, often the sorry if we calculate the charge of an ion, then we can say its oxidation number, okay. So next one is your oxidation number of oxygen is of the most compound is -2, okay, while the peroxides ions, that means the H2O2 or Na2O2, each oxygen atom is assigned as the oxidation number of -1, okay. So it is a simple contradictory fact, okay, exceptional fact. We have to remember that when there is when we are going to calculate about different metal peroxides, okay, then we have to think that the oxidation number of oxygen is here -1, okay. But in general idea, we can take the oxidation number of oxygen in -2, okay. But we can, when we are going to discuss about the superoxide like the KO2, like the rubidium oxide, okay, each oxidation atom assigns the oxidation number -1/2, okay. This is a exceptional one and it is a very important for the different competitive examinations also. So my dear friends, when we are going to discuss about the oxygen fluoride OF2, okay, here the fluorine is more electronegative than the oxygen, okay. And another example, when we are going to discuss about the dioxygen difluoride, okay, the oxygen is assigned as an oxidation number of +2 and +1 respectively. When we are going to discuss about the oxygen difluoride, the oxidation number of oxygen is +2, whereas we are going to discuss dioxygen difluoride, then the oxygen number is +1, okay. So this is the general idea, okay. So general idea, that means when we are found the more electronegative atom than the oxygen, then oxygen is act as the electropositive ion, okay, and the oxidation number is also changed there. The oxidation number of hydrogen is +1, but sometimes in metal hydrides, okay, in the metal hydride like the your calcium hydride, like the sodium hydride, its oxidation number is -1, okay. So this is the general contradictory fact. We have to remember the all the things, okay, my dear friends. And after that, all the in all the compounds, the fluoride have the oxidation number of -1, okay. Next one is sorry for the disturbance. So next one is the all the compounds, okay. So all the compounds of the fluoride, like the oxidation number is -1. So the algebraic sum of the oxidation number in all the atoms in a compound is must be 0. So my dear friends, this is the basic thing, okay. The algebraic sum of the oxidation number of all the atoms of a compound must be 0. So when we are going to discuss about the total oxidation number of the compound, that is 0, okay. So in the polyatomic ions, the algebraic sum of all the oxidation number of the atoms of the ion must be equal to the charge of the ion. So when we are going to calculate about the polyatomic ions, okay, then we have to calculate, we have to think that what is the charge of that ion, that is the algebraic sum of all the oxidation number. Okay, this is the idea. Okay, so after that, my dear friends, we have to discuss about the Stoke notation. So what is the Stoke notation? Okay, so representing the oxidation number of a metal in the Roman numericals within the within the parenthesis after the symbol or the name of the metals or the molecular formula and the name of the compound, like the Stoke notation of the ferric oxide, like the Fe2 third. Okay, so here the Roman letter is used. So what is the benefit of that? So here we can easily know about the oxidation number. Okay, this is the Stoke notation. This is also known as your Stoke notation. Okay, so here we have never confused about that. Okay, so after that, the fractional oxidation number. So what is the fractional oxidation number? So when two or more atoms of an element are present in the different oxidation states, and then the calculated oxidation number of the many comes out with a fractional due to the average of the oxidation number. So my dear friends, what is given here? So what is the fractional oxidation say? When two or more atoms of an element are present in the different oxidation state, then the calculated oxidation number may come out as a fractional due to the average of all the different oxidation state. So sometimes we have observed that the oxidation number may be fractional. Okay, due to the some due to the average of the different oxidation state. Okay, so this is the general idea. Okay, but in reality no element have the fractional oxidation state till now. Okay, but we cannot say in future the fractional oxidation state come. Okay, it may come. After that, my dear friends, the electrode or the redox couple. So what is a redox couple? A redox couple is defined as the is having the together oxidized and reduced form the substance, taking part of the oxidation and the reduction of half reaction. So we can say when there is a suppose you have you think that when there is a simultaneous reaction occurs, that means the your oxidation as well as the reduction reaction takes place simultaneously, then this first half we can say the reduction half reaction, or the second half we can say the oxidation half reaction, and the when we are taking the both of the reaction we can say the redox couple. Okay, this is known as a redox couple. And the electrode potential. Okay, so this is represented as capital E. So what is the electrode potential? So my dear friends, the tendency of an electron to gain or lose electron is known as electrode potential. So the electrode potential is the tendency of electron to lose or gain electron. Okay, after that, the standard electrode potential, that means we can abbreviated is it is as a capital E node. Okay, so electrode potential is measured at 298 degree Kelvin 298 Kelvin and 1 m concentration of the metal ion, that means the 1 bar pressure of the gas. Okay, this is when the two conditions are satisfied, we can say the standard electrode potential is occurred. Okay, after that, my dear friends, the electrochemical cells. So what is the electrochemical cell? It is a very basic thing. Okay, a device in which chemical energy of a spontaneous redox reaction is converted into electrical energy. Generally, electrochemical cells, okay, is a device in which the chemical energy of a spontaneous redox reaction is converted into electrical energy. Okay, so here you have look over here the figure here, the electrode potential, that means the zinc anode is dipped in the zinc sulfate solution, and copper cathode is dipped in the copper sulfate solution. Okay, so here both the redox reaction occurs and the voltmeter is attached, and when the voltmeter is attached, we have or connected, we have seen that the voltmeter is deflected due to the very low voltage difference. Okay, so generally from the above experiment we have concluded that this is in kind of your electrochemical cell. Okay, where the electricity electricity is produced. Okay, so this is the general idea about that. Okay, so after that some graphical representation are there. Okay, so generally it is a general idea, okay, about the redox reaction. So generally redox reaction is always accompanied by the oxidation as well as the reductions. Okay, so generally oxidation means the gaining of electron, okay, removal of hydrogen or loss of electron, and increase in oxidation number. But in the another hand, the reduction means the loss of oxygen, the gain of hydrogen, okay, or addition of hydrogen, the addition of electrons, okay, and the decrease of oxidation number. This is the general idea. Okay, so this is for today. We'll meet you in the next class. Till then, keep watching. Thank you, and not forget to subscribe.